screen and check, Yogesh sir,
Yes, sure, Manoj. Yeah.
annotations. Please check.
No, I think it is not there.
Okay.
Not able to see it.
Nestor sir, please check that. Give access.
Ma'am, I have already given co-host access.
It's okay, but annotation that that we can write on the screen. Right?
Annotations. I have also shared a whiteboard.
No, whiteboard will be beside the screen. That's there.
Yeah. Ma'am, I have already given co-host access.
Annotation is not there. Check. That we can write on the
Annotations. I have also shared a whiteboard.
Okay.
Sir, I think you will have to just check it out in the setting. Whiteboard is fine. If it is possible, maybe there might be an option for annotation.
Sir, we'll be checking from our
Yes.
side.
Sure,
We'll
sure.
be checking. Yeah.
Yeah.
Sir, are you able to access annotation?
Just a minute, sir. I'll check it out. I'll stop sharing once again share.
Yes, sir.
Yes. No, actually, it is not showing.
Okay, sir. Let me check.
Hey, just check it out if it is possible, sir. Otherwise, no worries.
Okay, sir.
Yeah. Okay, sir. I think it is, if it is not there, maybe I will use whiteboard then, no issues.
Yes, sir. I think you should use the whiteboard in that case.
Fine. Okay.
Yeah.
I'll just share my screen.
Yogesh, sir, we can start now. Shall we
Okay,
start,
ma'am.
Yogesh, sir?
Yes, madam. Yes.
Okay.
Am I audible? Next, sir.
Yes, sir.
Shall I start?
Yes, sir.
Sir, do you want to share screen? I'll stop sharing.
Next, sir.
Yes, sir.
Share
Shall I
the
start?
first screen.
Yes, sir. Yes, sir.
Okay. Good evening, everyone. Myself, Piyush Gangrede from ANTC Department, JSPM's Rajeshri Shahu College of Engineering. I welcome you all for 6 days online faculty development program on AI and its application in research. Today, I am your this session's coordinator. In today's session, we are with session expert Mr. Yogesh Murumkar sir, who will give an expert talk on end-to-end machine learning design. Before we start, I give some brief introduction of our session expert, Honorable Yogesh ji. He have total 11 plus year of experience, and he is currently working as corporate trainer for startup Bharat Software Solution, Pune. He also worked with he also worked for Capgemini India Private Limited, and also his work as senior trainer in generative AI, machine learning, deep learning, big data, and many more. So, taking too much time, I request Honorable Sir to start his session. Thank you.
Thank you, sir. Thank you. So, good evening, everyone. As the sir has already told you, we'll try to discuss about end-to-end machine learning flow. I'll try to show some examples as well. I hope so. It will help you to understand the things. Okay. I hope I am clearly audible to everyone, and my screen is also visible.
Yes.
So,
Yes, sir.
yeah. So, whatever the idea which I have, everyone, I think the participants are from different backgrounds. So, with that particular thing in mind, I'll be moving forward. Okay. In between, if anyone, any doubt, anything, you can always let me know in the chat box. And at the end, if any questions, if anyone is having any suggestions, definitely you can share that. So, I'm again saying, most of you are experienced people, definitely experts in their own domain. But as I have told you, considering all the participants, I'll be telling you the things from the scratch. And then at the end, everyone, I'll try to show you a complete end-to-end application. If we get time, we'll try to go and we'll try to see how to deploy a simple application as well. A simple machine learning application also. But to start with, everyone, I'll just try to start with simple terms. Okay. What is machine learning? What is data science? What is something called as deep learning? What is artificial intelligence? How these things are related. Many of you might have come across that kind of an explanation. Okay. But as I have told you, considering all the participants, we'll just try to discuss the things. And yes, at the start of the session, let me tell you, maybe later on, if someone is interested to go to implement the things practically, okay, so those who are interested, definitely, whatever the way I can help you, I will be happy to help you everyone at the end, definitely. Those who want to implement the things, those who want to go and see practical hands-on in more details. So if you want the code, whatever I'll be using here, whatever the files which I'll be using here, I'll be happy to share that. No worries. Okay. But I think most of you maybe might not have joined from your laptop or machines. So I'll just try to show whatever it is there on my machine. Maybe if you have any questions, you can always let me know. So to start with, everyone, as a topic is about end-to-end machine learning. So let's start our discussion with what is machine learning itself. Okay. Now, to talk about what is machine learning, everyone, as I've told you, we'll try to discuss about other terms as well. I mean to say other terms like data science, artificial intelligence. So how each and everything is basically related. Okay, that is also we'll try to see here. So okay, I'll just share a whiteboard. There I'll try to show a simple explanation here. I'll just stop sharing my screen and then we'll go to that diagram, whatever I was showing you. That is basically a complete flow. Okay, fine. I think you people are able to see the whiteboard. I'll just try to use it just to explain you the things, everyone. Something like this. Okay. So see all of you, I'll go with a very generic explanation here. As I've told you, those who are experienced, maybe you might have come across that kind of explanation earlier as well. But remember, okay, what I've told you is I'm considering everyone. Okay. So considering that aspect, I'll be explaining the things. So all of you, we want to discuss about something like machine learning. Okay. So in short, I'll just try to give an overview, you can say, because again, each one of this is vast. We will be discussing about end-to-end machine learning, but for that, I'll just give a basic idea. So to discuss about machine learning, everyone, as I've told you, there is not only machine learning, there are other terms as well. So the bigger umbrella, everyone, is always AI, artificial intelligence, which is a buzzword. Many of you might have heard about it. Many of you might be hearing about it daily, on daily basis. Now there is generative AI, LLMs, and all that stuff is also there. So that also I will try to tell you where that particular part is going to come into picture here. Okay. So we'll discuss about something called as artificial intelligence as well, in short. See, here I'm not worried about the standard definitions which are available on the internet, but in a very simple way, generic way, we'll try to see what is the meaning of these terms so that it will help everyone to understand the things properly. Okay. Even everyone, there's a very important term that is called as deep learning. So we'll try to see what is the relationship of deep learning with something like machine learning and artificial intelligence as well. And finally, there comes something called as data science. Okay. So other than this, there is something like data analytics, business intelligence. So where that also comes, and NLP, natural language processing, everyone. So in short, I'll give an idea about data analysis and then we'll move with the flow. Okay, we'll try to see complete machine learning project flow. Then I'll show a simple example. Let's say linear regression. I'll try to show how do we create the model, how do we convert that model into an application, and then how do we deploy that particular model. Okay, I hope this is good with everyone. But still, if someone is having any suggestion in between, always you can always let me know. And I'll request, please don't write down on this particular board because I'll be writing it down here, everyone. That's fine. Okay. In between, if you have any doubt, any suggestion, always welcome. No issues. Okay. So see all of you. If I talk about, if I want to talk about something called as machine learning, but the first thing everyone which will come into picture here is AI. Okay. Let's suppose if you assume that this is artificial intelligence, because everyone, you might have heard about artificial intelligence is a very generic term. You might have heard about that people say that AI is the bigger umbrella. It means everything comes under AI, artificial intelligence. So I know, like if I ask you what is AI, many of you might be able to answer it. Maybe if you Google, you'll be able to see a lot of standard definitions of artificial intelligence. But as I've told you, we are not worried about the standard definitions. We actually want to understand the meaning in a very layman way. Okay. So you can put down the definitions, everyone, all of you. If I let's say ask you what is AI, what do you think? Again, now it has become a very generic word, but still in simple words, some of you, can you just put down in the chat box for those it is possible? I think access is already given to you. See, if I ask you what is AI, can you just write down, everyone, in the chat box? What is artificial intelligence, so that I will also get an idea, right? Like, okay, fine, participants are aware about these things. I should be moving along like this. So what is AI, all of you? I hope you are able to understand my point and you are able to hear me. Just to start with a simple question, everyone. What do you think? What is artificial intelligence? A simple question. Right, wrong, anyway. But what do you understand? Okay, I'm not asking about the standard definitions available in some books or on the internet. Anyone? What is AI? I can say like more than 100 participants are there. Yes, I think I'm getting replies here. So, okay, Amruta madam is saying intelligence demonstrated by machines. Fine. Yes. Intelligence demonstrated by machines. Sheetal madam is saying implementation of human brain in computing. Yes, that's also right. Right? So like this, even there are a lot of meanings, definitions of this particular term AI. Okay. So I'll also write it on a very simple way. Okay. Sheetal madam is saying human brain. Fine. That is fine. Someone joined from OnePlus, putting learning in machines. Yes. Training machines. And machines are trained by giving intelligence similar to human. Jayashri madam is saying. So all these definitions seems right even. And other than this, there are a lot of standard definitions. But I'll put it like this even. Artificial intelligence is nothing but what? In simple words, it is just to enable computers. Or in general, as you people are using this particular word, right? Machines. Or even oblique, I can say computers. So to enable computers to think, right? This is what I can say to enable computers to think. To think like what? To think like human brain. It's a very simple definition in a very layman way. Okay? To enable computers to think like human brain or whatever some of the participants have also written, that's also absolutely right. And otherwise, if someone wants to make use of some fancy words, that's also possible. Okay? But in simple words, machine learning is nothing but what? To enable computers or machines to think. To think like humans. That is AI. But as I've told you everyone, AI is the bigger umbrella. Everything lies inside AI. For example, let's say if someone is new to this, or someone might not have done some hands-on. Okay. So just to make you understand, this is what AI. Obviously, AI is vast. Let me tell you, no one can say that, okay, I'm expert in AI. Not possible. Okay. There are a lot of things. AI is used everywhere, as you know. You just talk about the field. Artificial intelligence is everywhere. Every domain you talk about. Healthcare, transportation, security, military, sports, entertainment, real estate, finance, anything. Artificial intelligence is there. Okay. So we'll just keep it simple and small. Artificial intelligence is nothing but to enable computers or machines to think like human. Okay, I think you people have already learned about some other topics before this related to generative AI as well. Okay, so maybe there also you might have come across some. Next thing, everyone. Okay, so as I said, AI is definitely vast. Next thing, machine learning comes into picture. So machine learning, everyone, this is something which we'll be focusing and which we'll try to see the flow for machine learning. So machine learning is basically a subset of AI. And that is why everyone machine learning is going to come somewhere here. Okay. So again, machine learning, this word itself tells you. Okay. This word itself tells you what machine learning is. Machine is learning. Right. But still everyone, again, if I ask you what is machine learning, can anyone tell me in simple words, what do you understand by this? Machine learning, as you already defined AI in simple words. Like that, can you also define machine learning, everyone? Some of you. This is just to make sure that, okay, you are there listening. Okay. So, yes, I got a reply. Okay. Someone is saying that training data set provided. Okay. I think you want to say that training from the data set which is provided, right? Swati madam is saying machine is learning and behaving like human. Fine. Machine is learning and behaving like human. Someone wants to add something to that because I want to hear some words, some specific words as well. That is right. Machine is going to learn. And maybe it can behave like human, definitely. Jayashri madam is saying that making machine intelligent like human brain by learning from experience or data. Yes, that data term is there. Dr. Pradnya madam is saying just human learns. Machine also learn from experience. Yes. Mimic the human being. Yeah, that will go as a definition of AI, to be precise, Kavita madam. Ananta Chauhan, okay, decision making by machines. Yes, that's what machine learning does actually. Fine. So these things are right. Okay. So everyone see what I'll do is again for machine learning as well. If you check it out, even you will get lot of standard definitions available on the internet, or you go use ChatGPT and so on as well. You will get a lot of standard definitions. But to just make it simple, again, I'll put the definition of machine learning this way. Machine learning is nothing but, I'll just put it like this. It is just a bunch of tools. Okay, it is just a bunch of, to be more precise, even I'll do it like this. It is just a bunch of statistical tools. Okay. Now, why I written it like this, I'll tell you. Okay, I'll tell you in short. So machine learning is just a bunch of statistical tools. For what? For what? For learning. So this is how, as you people have used, right? It is going to learn from the experience of the data. Yes, it is going to learn. So machine learning is just a bunch of statistical tools for learning. From what, even from what? Someone has used this particular thing, the word data, right? Data. So to be more precise, even I'll put the definition of machine learning this way. Machine learning is just a bunch of statistical tools to learn from data. Okay. Now, hope you know what are the statistical tools. I'll just list down some of them. And everyone, I hope you know this basic term, data. Okay. Generally, I start discussion from that particular term itself, data. Without data, nothing is possible. So remember everyone, there is something called as data and there is something called as information. Okay. There is something called as data and there is something called as information. I hope you know this very well, that there is a difference between these. Okay. If someone is dealing with the data, if someone is working on some of the projects, definitely you should know the difference. Data is what, even data is a raw material. Information is processed data, meaningful data. Okay. In a very layman way. Let's say if someone is saying that, okay, there is something which is cold, there is something which is in the shape of a cone, there is something which is sweet. It's a data. But that thing is called as ice cream is information. In a very layman way, I'm going at it. Okay. So try to understand what in real time, what we get, even in real time, we always get data. That's what we get. That's why you might have heard many people saying that dealing with data itself takes a lot of time. That's what happens in real time. Your data might be coming from some databases like MySQL, or it might be coming from some files like CSV files, Excel files, JSON files, text files. It might be coming from some other databases like Oracle. It might be coming from some APIs, URLs, and so on. It might be a big data. So there are big data tools like Spark, Kafka. Then there is HBase, Hive, Hadoop, so on. Data might be coming from sensors. Data might be coming in the form of a key and value pair, if you are aware about dictionary, right? So most of the times, even what we deal with is data. But from that data, first of all, we need to get information. So there's a difference. Huh? That's what we get. Again, going and getting something like information from the data, everyone. Again, obviously, there are different techniques. With the help of Python, whatever the example which I'll be showing you, that I'll show you in short. In the flow, I'll show it to you. Okay. How we actually get the clean data, process data. I hope you must have heard about it. So it's a very basic thing. You see, you talk about machine learning, you talk about data science, talk about analytics, business analytics, data analytics, or even you talk about generative AI, natural language processing as well. We always get data most of the times. And whenever we say data, everyone, it's a raw material. From that raw material, we always try to get the information. We try to process it, pre-process it. We try to clean it. It means we try to remove the problems. Now, what are the problems? There might be redundancy, repetition, unnecessarily data might be repeated again and again. There might be blank or missing values. There might be outliers. There might be some columns which we do not need. There might be biased data. Okay. Lot of different problems even we come across in real time. So that's why I've written and highlighted these things. Okay. Just underline this. Machine learning is just a bunch of statistical tools to learn from data. Now, which are those statistical tools even? In a while, I'll just go and I'll just try to list down those tools as well. Out of which I hope you must have used most of them. Okay. We'll go and we'll just try to check it out. Okay. In between, if someone is having any suggestion, anything, you always let me know. Okay. I think you can always let me know in the chat box. I will always have a look at the chat box given. So see all of you, whatever the definitions which you people have given, definitely those are right. Like someone is saying that decision making by machines. Yes, that can be possible in machine learning. So there are techniques, there are algorithms, a lot of different algorithms possible in even machine learning again can solve different types of problems. There are approaches basically to solve the problems. We'll discuss about that one as well in a short. But yeah, just to give you a basic idea, everyone, this is how I can define machine learning. I agree that there are a lot of other definitions, definitely. But yeah, this is in short, it is just a bunch of statistical tools to learn from data. If you have any question, what are the statistical tools? I'll list down them. Okay, but for now, this is how I can define machine learning. Coming to the next one now, everyone. as we want to see the relationship between machine learning and other terminologies as well. So you might be knowing that deep learning, if I talk about deep learning, basically comes somewhere here. And deep learning, everyone, is very, very important. You might have heard that particular thing, right? Like, okay, deep learning is very, very important. So deep learning is all about making use of something called as neural network. Okay. It is all about making use of something called as neural network. And neural network, everyone, is nothing but what? Neural network is nothing but network of, I'll write down this word even, artificial neurons. Okay. Artificial neurons. If you talk about human brain, there are biological neurons. You might be knowing about it. Okay? Billions of neurons are there in human body. So here we talk about, let's say in terms of machines even, deep learning is nothing but what? It's all about making use of something called as neural network. And neural network, if I talk about machines even, it's a network of artificial neurons. And artificial neuron, it is represented something like this way, right? So if something like this, so what it has, everyone, it has input. Okay, it has input and it has some function. So some input will come here, and with the help of the function, then output will come. Okay. You talk about any type of problem statement, classification, prediction, a lot of things can be done. So everyone see, let's say a neuron is represented this way. You might have seen some diagrams as well. So you might have seen that, okay, a neuron is represented this way. So let's say suppose this is one neuron. So now what happens in neural network is there are different neurons in layers. So the first layer is basically input layer. Then second layer is nothing but called as hidden layer. And the last layer is nothing but what? Output layer. Now what happens is, if this is the input, okay, if this is the input layer and input data is coming from here, it can be image data, it can be text data, and so on. So what happens, everyone? All these things are interconnected with each other. Okay, just a brief idea I am giving you, everyone, because again, you can see it is something which is related to machine learning. Those who are aware about it, that is very good, no problem. Okay, fine. So you talk about any problem. Let's say I want to classify whether there's a cat or a dog in the image. Very simple example. Whether this is image data, let's say. That image data, everyone, will be converted into array. Maybe if you are aware about something called as NumPy, so that can be used. And it will be stored in the form of an array. And then maybe you will get an output. Okay, fine. Okay, there is a dog in the image or a cat in the image. So this is an example of classification type of problem. Or let's say if I want to classify a patient as diabetic, non-diabetic. So that can be solved. So again, a neural network basically looks like this. Okay. If you really want to get an idea, you can just go and Google TensorFlow Playground and you will see that it will show a whole picture. That is something which is provided by Google. That also I will try to show it to you. But yes, deep learning is all about making use of neural network. Neural network is nothing but network of artificial neurons. Artificial neuron is looking something like this, which is having input and some function. There are different functions even, like sigmoid function is there, which gives you output between 0 and 1. Okay. Then there is a rectified linear unit and so on. Softmax function is there, right? Different functions they are there. Again, that's not a topic which we want to discuss, but just a brief idea. So talking about deep learning, everyone, then there are types. There are different types as well. So in short, if I want to talk about it, then there is something called as artificial neural network. Okay, now artificial neural network, everyone, generally people say that it is something which is actually used for numerical data or text data. So it's not like that it is used only for numerical data or text data. It can be used for image data as well. But it has been seen that it gives good results in terms for that kind of a data, for numerical data. And that's why generally whenever there is numerical data, we use artificial neural network. Then there is something called a CNN. This many of you must have heard about. Maybe you might have heard many people saying that CNN is something which is used for image data. It is not like that it is only used for image data. It can be used for numerical data as well. But it has been seen that it gives good results for image type of data. And that's why many times people say that, okay, it is something which is used for image data as well. And then there is something called as even recurrent neural network. Okay. Let's say recurrent neural network, if I want to give a real-time example, even recommendation engines. Okay. Let's say if you talk about Netflix, you talk about YouTube, you might be getting, right, recommended for you. If you watch some video in YouTube, so you will get a recommendation. So that's a practical example where RNN is used. Recurrent neural network. So basically, they are like types of deep learning, everyone: artificial neural network, convolutional neural network, and recurrent neural network. Okay. So this is what I can tell you. Otherwise, deep learning itself is vast. As I've told you already, each one of these vast. No one can say, okay, I'm an expert in this or that. Not possible. Okay. Each one of these things is what? We'll focus more on something like machine learning. So in short, this is about deep learning, and why deep learning is so much famous, everyone, and so much important. It's a very small area in AI, but it's very, very important, because if you just go and check it out from since 2013-14, if you check it out, everyone, most of the problems of Google's AI. Okay, you might have heard about something called as Google's AI systems, Google's artificial intelligence system. So most of the problems of Google's AI, which are solved, they are solved with the help of this small region, everyone, that is called as deep learning. This small area in machine learning, which is inside AI, it is basically solved with deep learning systems. And that is why deep learning is very, very important. But again, if someone wants to go and understand deep learning properly, they should have an idea about machine learning, definitely. Okay. So that is how, everyone, I can tell you about deep learning in short. Otherwise, again, like it's, as I've told you, it's vast. Coming to the next one, everyone, something like a data science. Now, many times, again, you might have seen that many people write down data science as a part of AI. That's fine. That's right. But to be more precise, even I'll try to show data science this way. Okay. So data science is basically having an intersection with artificial intelligence. It is having an intersection with machine learning, and little bit of intersection it is having with deep learning as well. But in short, if I want to define data science, everyone, so I can define it this way. In short, that data science is nothing but what? Understanding data. Or maybe let's say making sense of data, right? Understanding data or making sense of data. That is what data science is. Okay. And something like visualization, even visualization or visualizing data is one of the most important aspect of data science. Otherwise, most of the things you will see, everyone, they are similar in data science and machine learning, but data science is more about visualizing. Obviously, you will be making use of statistics and all those things there as well. As you can see, it is having an overlap with AI, and overlap with machine learning, and overlap with a little bit of overlap with deep learning as well. That's why intentionally I just written it this way, everyone. So you can see it like this. So I hope you got an idea, at least what are all these things, everyone. Or maybe if someone was already knowing about it, that is fine, that is good, no issues. Now, as I've told you, there are some statistical terms as well, right? Now, we want to go and we want to focus more on something like machine learning, because that's our topic. So see now, everyone, if I want to list some of the statistical tools, see, as I said that machine learning is nothing but what? Machine learning is a bunch of statistical tools. For what? For learning. From what? From data. Data is nothing but the raw material. Information is what you get from data. Information is nothing but processed data, meaningful data. So which are those statistical tools basically? So everyone, to start with, there is something like probability, which everyone at least must have heard about. Whatever the background you are coming from, irrespective of that, I'm sure that most of you, almost all, must have heard about probability. So at least you should know what is probability. What is the meaning of that? Then everyone, there is something like linear algebra. Since school days as well, we have been solving different equations, right? Linear equations, quadratic equations. So let's say linear algebra. You might have dealt with something called as matrices as well, even. So let's say I'll write down matrix algebra as well. So linear algebra, matrix algebra, basic rules you should be aware about. Something like measures of central tendency, everyone. If someone is not aware about this particular term, measures of central tendency is nothing but what, even, which we have been using since school days, right? Mean, mode, median. Mean is nothing but the average. Mode is most repeated value. And median is nothing but the middle value. Along with this one, everyone, you will need something like measures of variability as well. So at least you should have an idea about these things, everyone. Measures of variability, like something like standard deviation. Then there is something called as variance. At least you should understand the meanings of these things. If someone really wants to go into AI or machine learning or data science, okay, then there is something called as range as well, right? What is quartile, percentile? You should know that. So other than this, again, there sometimes you might need something like numerical methods as well. At least the idea. What is the concept of derivative? What is the meaning of that? You should know that, right? So some of those I have listed, even there can be others as well, definitely. So these are the statistical tools, even, which like I can say they can come into picture when we talk about machine learning or even data science as well, everywhere. It doesn't mean that one should be an expert in this. At least they should have an idea about these things. Okay, so this is in short, everyone, whatever I've told you. Just maybe you can say it's just an overview of what is machine learning, what is deep learning, what is data science, what is artificial intelligence. But yes, AI is the bigger umbrella. Everything is going to lie inside here. And now, as you heard about a lot of other things, right? Data analytics, NLP, everyone, maybe NLP might be making use of machine learning as well as deep learning. So maybe that can come here somewhere here, right? So deep NLP with deep learning, NLP with machine learning, definitely you can do. And then everyone, there is like generative AI as well, which is also coming into picture, right? So obviously, maybe somewhere here that can come into picture, generative AI. So it is using large language models where you will require knowledge about machine learning, NLP, and so on, deep learning as well. If someone wants to go and someone wants to understand the technical details. So, and the analytics is everywhere, right? Analytics is everywhere. Maybe in the next session, then I'll show you one tool that is called as Power BI. So where we'll go, where we'll try to go and try to understand how data can be analyzed with the help of the graphs, how to create reports and dashboards. So basically how to do a simple analysis of the data with the help of a drag and drop tool where you don't require any coding, no programming language. So there are a lot of tools like that which are available. But again, with the help of Python also, definitely we can go and we can do it. Okay, but if someone is from such a background who doesn't know anything about programming, they can also go and they can also definitely work in the machine learning and data science and analytics teams as well, even with the help of your domain knowledge. Okay, at the end of the day, it's all about domain knowledge. Always remember. But knowing about these terms will not harm you, everyone. Okay, that's why at least if it is possible, and someone maybe is working in the research, someone is trying to work in the industry, or someone is trying to work on the project. So obviously you should have an idea. Those who are having the idea, that is fine. Okay, that is absolutely fine. So this is in short about machine learning, deep learning, data science, and artificial intelligence, everyone. Is that fine, all of you? I hope you are with me, everyone, those who are listening me. Some of you, can you just let me know in the chat box so that I'll also get an idea, okay, you are there and you are listening me. If some of you are having any suggestion, anything, you can always let me know, okay? That will again help. Fine, thank you all of you. I hope, yes, those who have replied. So it means, yeah, participants are there listening me and they are able to understand my point. In between any question, just put in the chat box, okay? Fine, I'll clear this one, everyone. I'll just try to clear these things. And let me show you the flow of a simple machine learning project. Okay, I'll just stop sharing my screen. Fine, thank you, sir. So I'll just stop sharing my screen. I'll share it once again, everyone, and I'll just try to show you the flow. Okay, obviously, everyone, by chance, if someone is from such a background who don't know anything about coding, but don't worry, okay, don't worry. As I've told you, if someone wants to try out these things, this file anyway, I'll be sharing. I'm not expecting that, okay, you should go and you should do it, okay, in such a small stipulated time, no worries. But try to understand, everyone, this particular flow, okay? As we want to talk about end-to-end machine learning flow. Because what I want to show you is, I want to show you a simple application, very small, but real-time application. What happens in real time? I want to tell you that even you also will be able to use my application. I'll try to deploy it as well. Okay, so that you will get an idea about it. Whether you have joined from mobile phone or maybe from your computer, you will also will be able to use my application. But how? Let's see that. So see, all of you, this particular flow chart, it's very common. Very common. Okay, but this is the flow chart, everyone, which is talking about typical life cycle diagram for machine learning model. Okay, so whenever we say machine learning model, okay. So model is nothing but what, everyone? Model is nothing but one file we create at the end. The extension of that file, if you talk about machine learning model, even the extension of those kind of files is .pickle, .sav, or .joblib. There are different extensions. Okay, generally we go with .pickle. These are like executable files. What are executable files? Like if you ever tried to install any software on your computer, or let's say if you have ever tried to install any computer games, you get exe files, right? We double click on that, next, and finish. So those are executable files, right? So everyone, here also we get something similar to executable file. If you try to open those files, you will not be able to see the contents. So whenever we say model, basically, those are those .pickle files, .pickle, .sav or .joblib. So how to create those things? This is the flow. So first of all, everyone, as you can see here, okay, we start with data selection. Now, whenever I say data selection, it means what is the source of your data? As I've told you at the start, everyone, right? Whether your data is coming from CSV file, Excel file, or a JSON file, or whether your data is coming from some website, or whether it is coming from a database like MySQL, Oracle, DB2, PostgreSQL, or it is coming from some other source, like some messaging technique, like Kafka, or if it is big data, whether it is coming from Spark, Hadoop. These are the tools, everyone, okay? If some of you are not aware about some of the names, don't worry. These are just the tools. Let's say if your data is coming from some social media platforms, it can be possible even. So depending on the type of the problem statement, always you will have some data source. Okay. It can be a streaming data as well, everyone. Now, once that data we get, everyone, what we try to do is we try to understand that data. Now in Python, there are a lot of packages. Some of the famous packages in Python, everyone, are like NumPy, Pandas, Matplotlib, and Seaborn. These are the names of the libraries or the packages or the modules available in Python. Every package has some purpose. NumPy, if I talk about it, even it is numerical Python. If you want to deal with numbers, arrays, we use NumPy. If you want to deal with if you want to fetch the data from some source, if you want to do analysis, we use Pandas. And if you want to do data visualization, we use Matplotlib and Seaborn. Okay. So see everyone, once we select the data source, we try to fetch the data. If specifically, if I talk about Python, so sorry. So I'll be making use of something called as Pandas to fetch the data from some files, from some data source. So I will try to describe that data. It means I will try to get an idea about the data. How many number of rows are there? How many number of columns are there? What are the data types of each and every column, right? How much storage space it has taken? What type of values are there? Whether it's a categorical data, numerical data, text data, date type of data, how many missing values are there, right? Blank values are there, and so on. So those packages, even which are available in Python, will help me to understand data. So that is what data description. Okay. Then we'll go and we'll try to perform something like statistical and graphical data analysis. So this is where everyone will require something like NumPy, Pandas, Matplotlib, Seaborn again, or Matplotlib for visualization. Matplotlib and Seaborn is for visualization. So we'll basically try to plot the graphs, scatter plot, pie chart, right? Bar chart. So we'll just try to visualize data, because as a human, it's always easy for us to understand the things with the help of the pictures and the graphs and the plots. Okay. Then everyone, we do transformations on the data if necessary. Now, what is the meaning of everyone? What is the meaning of this step? Transformation. For example, let's say as I've told you, in real time, we deal with data. So data, if I say data, it's a raw material. Now there can be a lot of things which are unnecessary in that data. Okay. For example, everyone, data transformation, if I want to give a simple example, it means there can be some columns where you have all the missing values. There can be some rows which are duplicated. Redundant data is there. So obviously having such kind of a data is not going to make any sense. Unnecessarily, it is going to increase the access time. It is going to waste the storage space as well, and a lot of other things. So we try to drop the columns. We try to remove the records. Sometimes it might happen that you have some column, but the data type is not proper. So we try to do typecasting. Typecasting is nothing but converting from one type to another. So with the help of Python, again, we can do that. Okay. If someone doesn't know Python, you have tools. In the next session, as I've told you, we'll talk about those tools as well, like Power BI. But the concept is not going to change. Okay. So we do data description, we do graphical analysis of the data, and then we do data transformation. So once we understand, okay, these are the problems in our data. So we go and we try to do transformations on the data. And when that is done, everyone, then we try to select a a suitable machine learning technique or an algorithm. I'll tell you, I'll list down the algorithms as well. So we'll try to list, we'll try to use a suitable machine learning algorithm with respect to what type of problem we want to solve. When I talk about machine learning, everyone, it basically solves different types of problems. Prediction, classification, clustering types of problems, okay? Which we'll discuss. So we'll do EDA. EDA is nothing but exploratory data analysis, where we try to deal with the data, we try to get the details about the data, and we try to observe patterns in the data. And then everyone, we try to standardize data, normalize it. Standardized data means what? Even we try to get the data at same level. It means what? It means the values in every column should be at the same level. It should not happen that one column is having the values in lakhs and other column is having the values like 0.1, 0.2 and so on. There should not be a huge difference between the values in each and every feature or the column. So if that is the case, even then your data is a biased data. We don't want biased data. Okay, we want a data which is not biased. So we try to standardize the data. How to do it? Again, that is also shown. I'll just take you through that one as well. Okay, the code is written. There's a library called as standard scalar. We will be using that. And then again, normalized data is nothing but what? Normalized means normalized data is such a data everyone where mean equal to mode equal to median. Actually, there is a concept of standard normal distribution which you might be knowing about. If you go and if you try to plot the graph for that, it is a bell-shaped curve. It means it's a data which is, if we divide it into two parts, those two parts will be exactly equal. We never get all the time, we never get like normalized data. We need to go and we need to do some operations for that. Okay, so we try to understand, we just try to get the data in such a format so that it should not be a biased and it should not be normalized basically. It should not be something called as skewed. Okay, otherwise, see, if you have those problems in your data, still you will be able to create the model, but your model will be a overfitted model. Overfitted model is the model, everyone, which will give very good accuracy at the time of training, but very bad accuracy at the time of testing in real time. It's like, let's say you are learning something at the time, you are really good. While studying, you are really good, but at the time of exam, you are not getting good marks, something like that. Okay. So we try to standardize the data and normalize it. Again, there are libraries. And then everyone, we divide our data into training and testing, and then we pass that data to the algorithm. And once that is passed, we create the model and we try to evaluate that model. We try to see what is the accuracy of the model. Now, there is no hard and fast rule that, okay, accuracy should be 99% or 95%. It again depends on the use case type of the problem statement. And then even if the accuracy is very low, if your team and the client team thinks that, okay, accuracy is not up to the mark, then we go and then we try to do something called as hyperparameter tuning. Okay, we try to adjust some parameters and then we try to do hit and try, and then we try to increase the accuracy of the model, and then we save the model. So save the model, everyone, whenever we save the model, as I've told you, it can be a .pickle file, .pkl, it can be a .joblib, it can be a .sav as well. And then finally, everyone, once everything is fine, we deploy the model on the cloud, which I'll try to show it to you. And then we try to get the project in the production. It means it will be using the real time and the testing. And then if there is a retraining approach to retrain it based on the data, if that is needed, that also can be done once it is actually deployed onto cloud. Okay, like WhatsApp is on cloud, that's how everyone can use WhatsApp from anywhere, anytime, any location in the world, right? Something like that. And then logging and monitoring, like how it is giving the results. If you want to show those things graphically for the client, all those things everyone can be shown. Again, there can be Power BI, Tableau, InfoView, a lot of tools can be used in. And finally, we can create the dashboards with the help of those tools. Okay. Swati madam, any doubt? You are raising your hand. Any doubt, anything, suggestion? Do you want to add something to this, Swati madam? Okay. Fine. Maybe then I think by mistake you done it. If any doubt, I think you can just put in the chat box as well. No issues. Okay, fine. So this is overall, everyone, the flow. I know, like, this is just an idea which I have given you. Now, see, as I've told you, everyone, as I've given you an idea about machine learning, AI, data science, deep learning, and all those things, let me tell you something more about machine learning. Okay, I'll just try to, just a minute. I'll just try to share the whiteboard once again. Fine. Now see everyone, as you got an idea now what is machine learning. So this particular thing, everyone, is what we want to focus, right? So as I've told you, machine learning can solve different types of problems. Because for this only I'll be showing you that application. Okay. So to solve different types of problems, even there are types. Basically, people say types, but actually they are approaches. Okay. So which are the approaches of machine learning, everyone? This you must have heard about, I think. Okay. There is something called as supervised learning. I just want to tell you a very basic thing here, which is important again. Then there is something called as unsupervised learning as well. Obviously, if supervised learning is there, then there can be a unsupervised as well. Okay. So unsupervised learning is another approach which comes under machine learning. Then there is one more, everyone, that is called as semi-supervised learning. Try to understand, everyone, this semi-supervised is something which we use in real time. Okay. Like when working on real-time projects at our organization, everyone, we actually use this one. How? I'll tell you. Obviously, then there is something called as reinforcement as well. Okay. Reinforcement learning is also there. So these are the 4 approaches, or people say like types, which come under machine learning or which can be used to solve different types of problems. Now, all of you see, supervised learning, it can solve 2 types of problems. Supervised learning can solve prediction types of problems, or regression also I can write on. Prediction means what? Let's say I want to create such a model which is going to predict the salary of a person based on his year of experience, based on his age, based on his previous salary, based on how much he has scored in the interview, and so on. House price prediction, it's a very simple example, very common example. Along with that, even it can solve classification types of problems as well. Now, classification means what? Let's say if I want to divide, if I want to classify a patient as diabetic, non-diabetic, which I'll be showing you, everyone. Let's say if I want to classify a student as pass, fail, right? Cat, dog in the image, all these kind of problems here, classification types of problems. These are the examples. Unsupervised learning, everyone, it can basically solve clustering types of problems. Okay, clustering. Many of you might be knowing clustering is nothing but what, everyone? Clustering is nothing but grouping. Okay, clustering is nothing but what? Grouping. In a very layman way, let's say, suppose, in a very layman way, everyone, let's say, suppose I have a lot of data. Okay, or these markers you consider as records. Okay, all these markers you consider as records in your data. So again, what clustering will do is clustering will basically divide this particular data into different clusters or groups depending on the properties. Now, let's say if you have a lot of marbles, now those marbles can be divided depending on their colors, depending on their weight, depending on their texture, depending on the size, or let's say depending on color. So white color marbles are coming, red color marbles coming here, blue color marbles coming here, and let's say something like pink color marbles are coming here. So again, it's a clustering. There's a difference between clustering and classification. Understand that, okay? So unsupervised learning approach even can be used to solve clustering types of problems. Okay. Coming to this one, everyone, semi-supervised learning, which I've told you that this is something which we use in real time. So basically, semi-supervised learning is nothing but what? It is supervised learning followed by unsupervised learning. Why? I'll tell you. Okay, why I'll tell you? Because many times I've seen that people are not clear about this. I'll tell you that this is something which we use in real time. Okay, it means we use supervised learning and unsupervised learning, both basically. Okay, now coming to reinforcement learning. Obviously, reinforcement learning is out of the scope of the discussion, definitely. But see, everyone, still, if I want to give you some real-time examples of reinforcement learning, everyone. So let's say reinforcement learning is also called as feedback-based learning. Okay, feedback-based learning, or everyone, it is also called as reward-based learning. Okay, feedback-based learning or reward-based learning. Why is it so? Why the name is like this only? Okay, see, feedback-based learning, why it is called as reward? Let me give a simple example. Let's talk about robots. It can be a very common example even, or let's say self-driving cars. All of you, all these things basically come under reinforcement learning. For example, a robot is there. Why it is called as feedback-based learning? So let's say a robot is there. Now on the next instruction, it is expected that the robot should move one step to the forward. But it is not doing that. It is moving one step to the right side. That means it is not doing the task as per the expectation. So in case of reinforcement learning, in a very layman way, what we do is, this particular robot, let's say, or this particular robot will be given a punishment, let's say, punishment. Reward will not be given, or a feedback will be given. And that feedback, everyone will be negative if it is not doing the task as per the expectation. Okay. And then that particular thing will be saved somewhere. If it is doing the task as per the expectation, give positive feedback or give reward. So that it will not make that particular mistake next time. That is the name. That's why everyone, that's why this kind of a name is there. Reward based learning or feedback based learning. Otherwise, as I've told you, reinforcement learning is definitely out of the scope of this particular discussion. Now, coming to the point, everyone, machine learning, as I've told you, it can solve supervised, unsupervised, and it has approaches to solve this problem, supervised, unsupervised, reinforcement. Now, when it comes to prediction is nothing but what? As I've told you, predicting salary of a person, predicting the mass of the students based on different approaches, based on different input features. So to solve these problems, even then there are different algorithms. A very basic algorithm, everyone, is linear regression, which I will also show you. Okay. Other than this, everyone, there are a lot of them. Okay. There are 10 to 12 algorithms which will come into picture overall. There is something called as decision tree. Okay. This is another algorithm, everyone. Algorithms are nothing but the techniques. At least if you know the idea about that, that will be enough, everyone. Now there are a lot of tools even which can directly go and directly use all these things. There is something, a very good algorithm, everyone, which we use in real time, many times, that is called as random forest. But to understand random forest, one should know decision tree. Then everyone, there is something called as gradient boosting. Okay. Gradient boosting algorithms are also there. One of the best algorithms is called as extreme gradient boosting. This is called as queen of machine learning algorithms. Then you might have heard about something called as k nearest neighbor. Then there is something called as support vector machine. Support vector machine is basically support vector regressor and support vector classifier. This is used for solving prediction problems. This is used for solving classification types of problems. Okay. So like these are different algorithms even. And talking about classification, all of you, talking about classification, for classification, we have a very basic algorithm called as logistic regression. Logistic regression is a very basic algorithm to solve classification types of problems. Other than this, even all these other algorithms can also be used for solving classification types of problems as well. Decision tree can solve both prediction, classification. Random forest same, gradient boosting same, XGBoost same. AdaBoost also is also there. Okay, AdaBoost is also there. This is another algorithm. I told you there are other algorithms as well. So for classification, logistic regression is one of the basic algorithms. Other than this, there are these other algorithms as well, which also can solve classification types of problems as well. Coming to clustering, everyone, there are some of the famous algorithms. One of the very basic algorithms is k-means. K is nothing but number of clusters. Okay, like 1, 2, 3 here. And there's another very good algorithm, everyone, which generally people don't mention. That is called as a DB-scan. Density-based spatial clustering applications with noise. If you have a big data, in that case, one can go with something like this. At least you should know the name. Okay. Otherwise, k-means is something which is generally used. So now what happens, even this is how we have the approaches of machine learning, and these are the techniques or the algorithms which are actually used. Now talking about something called supervised learning, everyone, always remember supervised learning is used for labeled data. Now what is the meaning of labeled data, everyone? Labeled data is the data. Labeled data is the data, everyone, where we have a label. Now what is the meaning of label, everyone? So see, very simple thing. Let's say suppose, I'll give a very simple example. Let's say suppose I want to create such a model which will predict the salary of the person. Okay. Based on age of the person, based on, let's say, the interview score of the person, how many marks he or she has got in the interview, and based on, let's say, written test score as well. Okay, something like this we have here. Okay, so we have different candidates for whom we have all these things. Let's say we have the data of previous 1000 candidates, 1, 2, 3, and so on. Right, all these details are there. So everyone see, and now we want to create such a model that if a new candidate comes, after 1000, if a new candidate comes, this is historical data, obviously. As you people have already told me in machine learning, what happens is we try to show the earlier data, historical data to the machine. And based on that, then we try to train the machine. So it means what even actually, it means even if I want to create such a model which is going to predict salary of the person based on written test score, interview score, and age. So salary everyone is my output, and all these remaining features are nothing but my input. So input everyone is also called as what? Input feature. It is also called as independent variable. It is also called as explanatory variable or input. Output everyone is also called as label. Output is also called as target variable. Output is also called as dependent variable. Output is also called as explained variable. Okay. So I think it is deleted. Just a minute. Okay. Output is also called as explained variable. So label. So it means even wherever you have been given the label, that is target variable output along with these inputs. That means whenever you have an idea, whenever you are considering something as output, then only you can use supervised learning approach. Like in this kind of example, even marble, I've told you, right? Let's say you have a lot of marbles, but you don't have any idea about what is the output, what is the input. So you cannot solve that particular type of problem with the help of supervised learning approach. You try to use unsupervised learning. So even for supervised learning, labeled data. Okay, labeled data. And unsupervised learning can be used even whenever you have the data which is not labeled. That means what? That means you don't have an idea about label, or you are not considering any feature as a label. Please try to understand that. Okay. Now coming to semi-supervised learning, everyone. This one, as I've told you in real time, basically this is what we use. How everyone see? I'll just clear this. What happens in real time, everyone, is generally we get some data from the client. When we also work on the projects at our organization, even we get some data from the client. Now that data basically is not only one file. Like this, there are a lot of files again. So let's assume that it's a very huge data, and data comes on some intervals, maybe after 5 days, 10 days, every 15 days, every week, every Wednesday, Thursday, something like that. So everyone see what happens is we never apply any algorithm directly. What we do is depending on, so let's say this is the data which we have been given everyone. And now let's say suppose everyone, we want to solve classification types of problems. Okay. Can we, Reshma madam, I think anyway you are going to get recording. So in that case, anyway you will do it, right? You can take the pictures, no issues. I think in the recording itself you will be getting it. So I think that will not be a problem for you. I hope you got my point, right? You can, through the recording, you can always go and take the screenshot. I hope, right? It makes sense. Yeah, fine. So see now everyone, if I have a lot of data, generally in real time, what we do is, let's say I want to solve a problem which is classification type of problem. Now I've told you everyone, for classification, we have a basic algorithm called as logistic regression, and then decision tree, random forest, k nearest neighbor, XGBoost, and so on, support vector machine, and so on. But do we apply directly a classification algorithm? No. Even if we know that, okay, this is the output, this is the input, then what we do is, as the data is huge, so we never apply classification or any regression or prediction algorithm. We divide this data into different clusters. This is one of the very common approaches even across the industry which is followed if you talk about creating the model from the scratch. So now see everyone, what happens is we divide this particular data into different clusters depending on the similarity. Like let's say if I talk about the example of the marbles. So even similar kind of data will come into one cluster. And the data which is dissimilar, obviously that will come into different clusters. This is how it is going to happen. So let's say, now let's say I got, see, every time you are not going to get 3 clusters. It totally depends on the type of data. 3 is just the example which I am showing it to you. Okay, that also you try to understand. Now everyone see, let us suppose this is 0th cluster, this is first cluster, and this is second. So actually what have we have divided this particular data into different clusters. Now let's say I applied an algorithm called as k-means. K in K means is nothing but number of clusters. So what is the value of K in this case, everyone? 3, because we got 3 clusters, 0, 1 and 2. So basically we applied what, everyone? We applied unsupervised learning approach. That means, did we consider anything as a label, anything as an output? No, we did not. We did not consider anything as an output. So, but we know that we wanted to solve classification type of problem. Classification type of problem can be solved with the help of supervised learning approach. Supervised learning approach can be applied to such a data which is labeled data. That means we know the output. But did we apply any classification algorithm? No. If you remember the names, did we apply any classification algorithms? No. First of all, what we done is we clustered that data. Now I got different groups for the clusters. And now everyone, as my problem is a classification problem, what we do is on this cluster, we apply different classification algorithms. For example, let's say I'll apply logistic regression. Let's say I'll apply random forest. Let's say I'll apply K nearest neighbor. These are nothing but the names of the algorithms or the techniques, everyone, which comes in machine learning. So we never depend only on one algorithm. Always remember that. Generally, people ask, okay, how to decide which algorithm to use? There is no hard and fast rule. It's always hit and try, everyone. But again, if you have a knowledge about the algorithm and if you have knowledge about the data, domain knowledge, it always is going to help you. So logistic regression, random forest, KNN is just an example. In real time, we go and we apply 5 to 6 algorithms. Okay. Same algorithms, all of you, we go and we try to apply on the remaining clusters as well. Here as well, again, the same thing, all of you, which is going to happen. Logistic regression, random forest, and K nearest neighbor. And then all of you, whatever the algorithm which is going to give me the best accuracy. And not only accuracy, everyone, not only accuracy, the algorithm which is going to give me, like if I talk about classification model, we evaluate classification models not only based on accuracy, but there are other factors as well. There is something called as precision, recall, and F1 score. So for now, I'll say accuracy. So whatever the algorithm for which we are having the highest accuracy for this model, that model is our final model for that cluster. So let's say random forest for this one. For this one as well, let's say random forest has given me the highest accuracy. And for this one, let's say even KNN has given me the highest accuracy. Okay. So now what happens is, now these are my models. Like as I've told you, pickle files. Right? Pickle files. So now everyone, what happens is, this is training. This is training. Now when testing data comes, let's say this is my testing data. Now the testing data also, we go and we try to divide into different clusters with the help of unsupervised learning. And then everyone, depending on to which cluster it belongs. So this data basically, let's say, belongs to 0th cluster. So that data will pass it as an input to this particular cluster, this particular model. This data will pass as an input to this model. And this data, everyone, will pass as an input to this model. Whatever is the best model. This is how we do it. So basically what happens, everyone, we apply unsupervised learning and then supervised learning. That is why I said that it's a very common approach in real time, which we follow across the industries. Okay. Not compulsory, but most of the time, this is what we do. Right? To answer your question, Lakshman sir, to answer your question, what will happen if you haven't used clustering? You can get the model, no problem. But one of the main reasons of dividing your data into different clusters is what? See, the speed of the training will increase. Why? Because can you see, this will be like parallel processing. Are you getting my point? Instead of going and executing, applying all the algorithms directly on big data, we are dividing those data into smaller chunks. And then we are applying the algorithms on that. So what will happen is parallel, this will also be going, this will also be going, this will also be going. So whatever the machine's processing power you have, you can definitely utilize that. Are you getting my point, sir? This is one of the reasons. Like this, there are a lot of other advantages as well. But yes, this is one of the main reasons. I hope it makes sense, Lakshman sir. That's why, right? Because obviously it will help you process the things faster way. Lakshman sir, I hope you are there. I hope that answered your question. I hope you got the point. Why we actually divide the data like this, okay? This is one of the approaches, okay? As I have told you, that's what happens in real time, because your data again will be coming from different data sources. Generally, we try to even combine that, we try to solve the problems. So that is the reason why we follow. But again, as I have told you, it is one of the approaches. Again, what people do, everyone, they create the pipeline, make it ready, and then they try to follow it. Even nowadays, you will see on many of the cloud platforms, everything is ready. You just need to go make your data proper, clean, pre-process, ready, and then it will go through the pipeline and maybe you can go and you can utilize it. Right? This is one of the ways when it comes to end-to-end projects. Let's say if I want to use only one algorithm just for a sake of showing you, I will also show you directly that, okay, I have a data and we'll apply these algorithm, any of these algorithm basically on that particular data. Okay. So I hope that makes sense to others as well. Okay. As I've told you, it is one of the approaches. Okay. Fine. But still, if you want to add something, you can always let me know. So that is one thing, everyone. Now what I'll show you is, I'll just try to go through a simple example just to show you the flow. Okay. So I think I will have to stop whiteboard just a minute. Okay, I'll share my screen with you once again. Okay, so I hope you are able to see that flow diagram once again. This is what I have told you in short. Even later on, maybe those who are interested, you can always go through this. So see, all of you, I'll go with a very simple example. Okay, very simple example, because our purpose is just to understand the flow, right? How actually end-to-end machine learning model is created. So you can see here I have some sample data. Here I think. Okay, very common data set that I'm using. You might have come across that kind of example. Let me show you that. Yeah, this one. Okay. Simple. You can see again, Excel file, CSV file. Yeah, this is the data. Admission prediction is a very common example, all of you. See, it's a labeled data. Okay, it's a labeled data. So dynamically, we have to choose algorithm for n clustering. Yes, sir. Yes, like. But as I've told you, most of the times it is k-means. Most of the times. But DBscan, the example which I've given you, generally it is used whenever you actually deal with big data. Density-based special clustering applications with noise. Noise is nothing but the errors in your data, unnecessary things in your data. So yes, you can dynamically use which algorithm to choose. Specifically for clustering, most of the times you will see k-means is used basically. It is one of the famous algorithms. Okay. I hope that answers your question, sir. Okay. In my case, yeah, fine. In my case, I have not used clustering because it's a simple example which I'm showing you, because again, flow is what I want to highlight here. Okay. So see everyone, those who are aware about this data, fine. Those who are not, for them. So see everyone, we have this simple data set. Okay. All these things I'll just share with the organizers. You will get it. Don't worry. Later on, you try to go through recording and check these things. Serial number we have, so we have the data of some of the participants who basically applied for masters in some foreign university. Now, everyone, whenever someone wants to take some admission in some foreign university, there are exams like GRE, TOEFL, test of English as a foreign language. So everyone, we have serial number column, GRE score. GRE score is out of 340. TOEFL score is out of 120. University rating for which you are applying, it is out of 5. SOP is nothing but statement of purpose. Maybe many of you already submitted your statement of purpose. So those who want to go for research, even those who want to go for masters, many times many universities ask them for statement of purpose. So statement of purpose is having 5 marks. LOR is nothing but recommendation which you get from your project guide or maybe principal, let's say. GCPA, everyone everywhere, very well. Marks, it is out of 10. LOR is out of 5. Research is a categorical type of data. That means that person has done some research or no. So yes or no. Let's say 1 is yes and 0 is no. Why am I saying let's say? Because see everyone, we really don't know. 1 is yes and 0 is no. What client has done is client has already converted everything into numbers and they have given us this particular data. Okay, so let's assume that 1 is yes and 0 is no. Sometimes if they are not converting everything into numbers, then we will have to convert. So we can use Python and other techniques. Okay, and then even chance of admit. So what was the chance of the admission of this person who has got 337 marks out of 340 in GRE, who has got 118 marks out of 120 in TOEFL, and so on. So his chance was 92%. Second person, 0.76, 76%, and so on. So see everyone, if you look at this particular data, this is our output. And all these are nothing but what, everyone? These are nothing but our input variables, input features, independent variables, explanatory variables. This is our target variable, label, dependent variable, explained variable, output. So it means we are aware about the label. It means it's a label data. It means Now, if I want to go and if I want to create such a model from this data, you can see 500 number of records are there. So I want to create such a model now. If 501 person comes here and if we enter all these details, I want to create such a model which will predict what will be his chance to get the admission in foreign university. But that model will be trained from what? From all these 500 records. Okay. But there are some problems in this data. Can you see here? Some of the participants did not enter their GRE mark. It might not appear for GRE, that's why. Some of the participants did not enter their university rating. The reason can be anything. We really don't know. So everyone, it means these are missing values. Now, we should not have missing data. Missing values, null values. Okay. They can cause the problems like this, like this. So we'll handle those as well. It means this is data. We'll try to process it. We'll try to clean it. Okay. And then we'll pass it to the algorithm. So I hope everyone, you got it. What we want to do, all of you, we want to create such a model which will basically help us to predict the chance of the admission of that person to get admission in foreign university from masters, if he enters the details of all these things. Okay. Diya madam, if you have any doubt, I think you can just let us know in the chat box. I think you are raising your hand. If anything, please let me know. Okay. Can you predict that missing data from the past? Missing data, then you will have to create separate model format. We cannot predict. Okay. How do we handle missing data generally? Either we remove the entire record, we remove the entire column, or we basically replace that missing value either with mean or mode or median. We use mean median if you are numerical column. Okay, and when do we use median? If we have outliers, then we use median, otherwise mean. If you have categorical data, then you replace that missing data with the help of mode of that particular column. But if you want to predict that, yeah, so again I'm repeating it. If you are saying that can you predict, for prediction basically, then again what you will have to do is you will have to create a separate model. You will have to consider that column as an output column. Are you getting my point? Right? You will have to train it and then maybe you can try to predict it. But that's what not we do. If there's a missing data, we handle that, because see, here it is very clear now. What we want to do is we want to create such a model which will predict this. That's why this is our output. Okay. So if we have this kind of data, what do? We try to either remove the entire record where we have missing value, either we remove the entire column, but removing some records and column might lead to loss of data. Depending on how much data you have, if you have a lot of data, you can think of removing the records and the columns. But sometimes removing the records and the columns might lead to loss of data. If you don't have enough data itself, how can you create the model? It's like if let's say a teacher is not teaching to a student enough, how can he pass the exam? It's like that. Or if a parent is not teaching enough things to the kid, how can he learn, right? How can he survive in the life? It's like that. So if we are not giving the enough experiences, obviously our model will not be that much, we can say it will not be able to predict that much accurately. So what we do with missing value is we basically remove record columns. But if you don't have a lot of data, we don't do that because that might lead to loss of data. We replace this missing value either with mean, mode, or median. Now, when do we use mean and median? If it's a numerical data. But out of mean median, when do we use median? If you have numerical data, but your column is having outliers in your data. Now, what is outlier? Outlier is nothing but extreme value. Extreme value, right? I hope you understand. Why? Because mean is affected by outlier and median is not affected by outlier. Because median is what? Median is nothing but the middle value. Mean is average. I hope you are getting my point. And if it's a categorical data where you have missing value, then we replace that missing value in categorical data with mode. Mode is nothing but most repeated value. You can see research done, not done, yes, no, pass, fail, male, female, categorical type of data. Okay, so there we use mode. So I hope it makes sense, madam, right? When to use mean, median? Yeah, I repeated, Lakshman sir. I hope you got my point. Lakshman sir, right? When to use mean, median? If you have numerical data. Okay, yes. And your doubt is also created. I hope ask me that. Disha madam, I hope, right? Did who ask it? Disha madam, right? I think you asked. I hope that's clear. Fine. Okay, fine. Okay. Anil sir is asking, sir, the recording. Yeah, they will give it to you, sir. They will give it to you. Okay, fine. Anyway, so see all of you. I hope you clear now what we are going to do. This is our output. Okay. So quickly, I'll go to the file even where I have created the model. Now what I'll do is I'll simply take you through the steps. Later on, you please refer these files. If someone really wants to understand everyone, at least one example, you do it properly. Okay. So see all of you, I'll be showing you uh, the application as well. Whatever you people are able to see everyone is what? It's a Jupyter notebook. Okay. It's a Jupyter notebook. In this Jupyter notebook, all of you, everything is given. Data cleaning, data pre-processing, what is linear regression, code is given, maths is given, explanation is given, and deployment steps are also given. Everything is given. Okay, so you later on refer this. So see all of you, linear regression if I talk about. Now, linear regression basically makes use of equation of straight line. Just in 2 minutes, okay, I'll just show you what is the basic idea behind linear regression, okay? And then we directly move to the code again. I'll stop this. So I'll just show you again. Linear regression is one of the very basic algorithms, okay? As we already used it in our example again, that's why I'm using it. Okay, so see all of it. Linear regression. Linear regression is what? It is going to help you to predict. Now, linear regression even is, it makes use of equation of straight line. Y is equal to mx plus c, which we have been learning from school days, right? Where m is nothing but the slope. What is this c, everyone? Is nothing but the y-intercept. Okay. X here, everyone, is nothing but what? X is nothing but the input. And y is nothing but output. Now, in many books, you will see that this particular equation is written this way. Y is equal to beta 0 plus beta 1x. Or y is equal to, let's say, b0 plus b1x. Again, one and the same thing. Beta 1 is nothing but the slope. Beta 0 is the y-intercept. X is the input. Y is the output. Now, everyone, this particular thing is nothing but what given? It is simple linear regression. Why it is simple linear regression, all of you? Because there is one input, one output. But in our problem statement, do you see? There are multiple inputs, one output. So that equation is going to become something like this. Y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus and so on plus beta and xm. What is this, everyone? This is multiple linear regression. This is what we are going to use to solve that particular problem to create the model. So all of you, in short, as I've told you, what all that code is going to do is very simple thing. See, concept of equation of a straight line is very easy, right? That's what linear regression is totally based on that. That's what that basic maths one should know, at least a basic idea. So see all of you, let's suppose I have some example here. Let's say, any example, let's say. Okay, something like this. So let's say suppose that even here we have score, okay, test score of the person. And based on the test score, let's say, we want to go and we want to predict the salary. Sorry. We want to predict the salary of the person. Okay, salary. So again, it means this is my input, this is my output. Okay. So all of you, let's say we have been given the data. Okay. So we'll plot the graph like this. We have been given some data like this area, like this, and so on. So we have a lot of data. So what we do, everyone, is with the equation of straight line, we try to come up with such a line which is going to pass through all these points, but in such a way that that line is going to pass through dense area. Dense area means what, even? Dense area means where there are a lot of data points. That means near to that line, there will be lot of data points. It means what, even? It means the distance of that line from all these points should be as minimum as possible. This distance, this distance, this distance, this one, this one, this one, this one, this one, right? This distance is basically called as error or residual. So ideally, if it is 0, that means your model has 100% accuracy. So what basically is going to happen, even if this is your input data, test score 1, 2, 3, 4, 5, and 6, and salary is, let's say, 10K, 20K, 30K, 40K, and so on, right? And 50K. Now, everyone, it means if a new person comes and if he is having test score as 5.5, so you can always predict it with the help of this particular line. This particular line even is called as line of best fit or best fit line. Best fit is a line even which always passes through dense area. That means the distance of that line from all these points is as minimum as possible. So see, all of you, if you want to predict how much will be the score or how much will be the salary of the person if the score is 5.5. So what actually happens in the backend is, in the backend, everyone, something like this is going to happen. So let's say it's like this. There will be a perpendicular line from this, which will basically cut line of best fit, and from that point basically we will draw another line which will cut y-axis. So whatever the value which you are going to get here, let's say this is 35K, so 35K is going to be your prediction, because even you know the nature of straight line is always straight. It's not going to happen that after some point of time it is going to become like this. No, absolutely not. That is the basic idea we are using in linear regression. This is the whole idea, everyone. Okay, what you do is, after this, everyone, what you do is, how can we implement machine learning? Yeah, that's what I'll show you now. I'll show you one example. Later on, you go through that. Okay? It will not take much time. So see, all of you, that's what I have shown it here. Okay, whatever I was trying to explain everyone about linear regression, because that is the algorithm which we have used. And if you are asking me real time, I already given an idea that we go, we cluster the data. Someone is joined as Vivo V2123132. Please listen. We go with cluster data in different clusters, and then we apply more than one algorithm in real time. Okay. So see, now I'll directly come to the problem statement. If someone wants to go and check out the things in detail, please refer this one as well. Like line of best fit, simple linear regression, multiple linear regression, what is residual, mathematics involved, how derivative is going to come into picture, right? All that stuff, everyone. How to find out the minima. You please check these things out, all of you. Everything is given here. But in short, I was just trying to tell you what are the steps basically we apply. Statistics, hypothesis testing also, if you want to go and check it. So that's what I said. Not only this algorithm, all these things will be required for all the remaining algorithms as well. Okay. So quickly, I'll move to that particular problem statement. How to clean your data, how to process your data, everyone. All those things are basically given. So the data set which I have shown you, everyone, see what are we going to do. NumPy pandas, I am going to use it. These are the libraries available in case of Python. NumPy pandas is basically used to fetch data, to describe data, to do data analysis. NumPy is used for numerical Python, for converting your data into arrays because they are extremely fast. Standard scalar, do you remember, everyone? This is for what? This is for making your data standardized. It means every column should have the value at the same level. It should not happen that one column is having very high values and other columns are having very low values. That means it's your data is biased. We do not want biased data. So there's a library called as standard scalar. Don't worry about all these things, even. You just check this linear regression. Whatever I've told you, line of best fit. So that algorithm we are using here, and I'm importing it from sklearn. Sklearn is again a library where all the machine learning algorithms are present. Okay. And then even this trend test split is going to do what? Trend test split is a method, even, which will help you to split your data into training and testing. If your data is there, then what we do is we basically divide the data into input and output first. Input is denoted with X and output is Y. We divide that input and output into training and testing. Maybe someone is knowing, if you have tried to read anytime, 70% is training and 30% is testing. It's just an example. It can be 90, 10, 75, 25 as well. So this particular method is basically used to divide your data into training and testing. And then matplotlib and this seaborn even is just for visualization. Okay. You don't worry about this. If you want to go into details of this one, please just read the theory which I have given. What are we going to do, everyone? See, this is the file which I am going to read with the help of pandas package. Okay, admission_prediction. Okay. Yes, sir. You can. I'll recommend you use something like VS Code, because in VS Code, sir, you can go and you can basically in VS Code you can basically open IPYNP file. So as compared to Python, I'll go with VS Code. You can open it in PyCharm as well. No issues. So see, again, we are reading this data. Then I am describing the data, just understanding how many records in each column. You can see GR is having some less number of columns. Actually, I have 500 number of records, but GR is having 485. That means there are 15 null values there, 10 null values. Okay. Then even what am I doing is I'm taking care for missing values. See, I'm using mode, median mode, mean mode and median according to the type of the column. Again, describing now every column is having same number of records. That must be taken care for missing values. Then everyone, I'm dropping serial number because chance of the admission doesn't depend on serial number column. Okay. Then what am I doing, everyone? I'm just trying to plot a distribution plot. This is just one command. Okay. It's simple Python, everyone, but this is just one command with the help of which we are getting a graph like this. So I'm just talking about distribution of data. It should be normalized. It means you should get a proper bell-shaped curve. So I'm just checking it out, and then I'm dividing my data into input and output. This is our output, everyone see. So this is our output basically, and input is X. That means other than in output, we are assigning all the other columns to X, and then we are trying to plot scatter plot just to check out the relationship between input and output. Why? Because if output is not dependent on some input column, why do we use that particular column then? Okay, we should not use. But you can see almost every column, every input feature is having linear kind of a relationship with the output. You can see, everyone, on the y-axis we have chance of admit, and on x-axis everywhere you have all the inputs, GRE, TOEFL, everything. And then finally, everyone see, this is what I have told you, standard scalar. It will transform our data. Okay, don't worry about this. Later on, just check it out, this file. VIF is just for multi-collinearity. It is not mirrored here, but still I have shown it to you. Then again, this is how I'm going to divide my data into training and testing. 25% training and 75% training. 25% testing and 75% training. Okay. So now finally, this is how we apply the algorithm. You just need to call this method, create an object of that, and dot fit. Whenever you use dot fit method, that means actually you are showing the training data. X is input, Y is output. I am showing input training data and output training data. So 500 is there. That means 350 number of records I am showing as input and output to my machine. And then again, how do we save it? See pickle file. And we dump that pickle file. W means write and B means binary. We dump that pickle file. Whatever we have given, we dump everything into pickle file. It's an executable file. And then everyone, if I want to use the model, I can use the model in Jupyter Notebook itself. See, here I used. This is nothing but what? GRE score, TOEFL score, university rating, letter of recommendation. This is CGPA, research done or not. Okay. And all the input columns. And then again, can you see it is predicting 92% of the chance. So this is what a simple model everyone, which I shown you in Jupyter Notebook. But one last thing, what we do all of you is, whatever the pickle file which we create, if I want to convert my model into a web application, a mobile application, if I want to use my model on some website, I can use that. So just one last, what we have done is, again, those who are not aware about Python, fine, but at least understand. So what we do, everyone, is what I've done is, whatever that pickle file is, this pickle file I utilize here, that pickle file you will get in your current folder. And I written a simple Python code in this file. So here I use something called as PyCharm, or you can go with something like VS Code as well. So I written a Python code. If someone wants to convert that file, see, you cannot give a Jupyter Notebook to a client. Client needs UI. Okay. So everyone see what I've done is, I converted that particular pickle file into application. One can use it into as a mobile application as well, definitely, if you know about the languages. But yeah, something like this is going to happen again. At the end, this is what we need to give to the client, right? If you talk about, let's say, an end-to-end project. So see, all of you, again, now don't worry about the code. I'm not expecting that you should aware about the, you should be aware about Python. But if someone wants to go, someone wants to explore, definitely you refer that file, whatever I have shared with you. Just a minute. Yes, fine, Lakshman, sir. I'll see. So, all of you, whatever I have done till now is what I have got this file, and that is what I am using in this program. Okay, that is the file even which I am using in this particular program. So just let me show you everyone. Let me just show you a simple example here. I have used something called as Streamlit. Okay, it's a framework basically. But okay, Streamlit. I think the name of the file is main.py. Okay, so whatever I shown you in Jupyter Notebook, same inputs I am going to enter here as well. Okay, Same inputs even I'm going to enter here as well. And now can you see a fancy looking page is created and something like this. So see, now if I enter GRE score, GRE was out of 340. Let's say someone has got 321 marks. TOEFL also out of 120. Let's say someone has got 111 marks. University rating out of 5, let's say 4. Segment of purpose, let's say someone has got as 2 out of 5. Letter of recommendation, let's say 3. CGPA out of 10, let's say something like 7. And do you have research experience? Let's say yes. So yes and no you can use. Let's say yes. Now everyone, if I go and if I click on this, predict admission chance, it will tell you in percentage what is the chance of the admission. You see, 51.52% is the chance. Now you want to use my model, everyone. Even I have deployed this particular model on the cloud. I'll just link it. Just a minute. Okay. So I have actually used a free cloud called as Streamlit, where I already deployed it. Anyway, if I'm not able to show it to you here, but you can do it again. Steps are also given in that file as well. You can always try it anyway. So see, Streamlit is a cloud again. Anyone can use it. It is free. It will not ask you for credit card, debit card, something like that. So see, again, today itself, before this session, I deployed this model. Same application I deployed on the cloud. I given the name as me1234 Streamlit. Now, if you want to use my app, everyone, see, I'll just copy this link. I'll just share it in the chat box. You click on that link, everyone, and just tell me whether you are able to use my application or not. Can you just click on that, everyone? If you click on that particular link, you should be able to see this. Why you should be able to see, everyone, now? Because it is running on cloud. It is not running on my local machine now. It is running on cloud. Now, how I deployed it, if you really want to know about that, again, it is given in my file. It's already given in that file. Okay. Can some of you just go click on that and can you just confirm, everyone? Are you able to access that, all of you? Can you just confirm, everyone? Just need to go click on that particular link which I shared you in the chat box. And just let me know. Yes, it's working, right? Fine. Thank you, sir. So see, and those who want to know about how to deploy it, it's very easy, but still if you want to know about how to deploy, everyone, if you are interested and if you want to do these things, once you get these files, whatever I have shown it to you here, those who want to go and those who want to check it out, even you can always check it with my name, and yeah, you can always go check it out here even. I have shown it here many times actually on different clouds basically. You talk about Amazon, you talk about Heroku, you talk about Streamlit as well. So those who are interested, they can also check here as well. Okay. So obviously, those who are interested, they can go, they can check it out. Okay. That is actually my YouTube channel. You can always go and check it out if you are interested. Okay. So that is in short from my end, everyone. I think I hope I am able to explain you the concepts. I hope you got some idea. I know with stipulated time, with this much of stipulated time, understanding everything is not possible. But still, if you have any doubt, you can ask. Okay. Anyone any doubt? Otherwise, I think it's already time. Okay, I hope you got some idea, basic idea, all of you. Later on, you go and you explore the things with the files which I'll be sharing. If you are interested, definitely you can go and you can check. Okay, email ID I will put it anyway. If you have anything, email ID I will put in the chat box. If you want, yeah, you please check it out. Yes, sir. I'll share with the organizers. They will share with you. Okay. Fine. Sir, if any question, you can let me know, all of you. I hope it has given you some idea. Now, I think in the next session, we'll talk about Power BI. Okay.
Good evening, sir. I have a question, sir.
Yes, sir.
Sir, can we also do like all these things with the deep learning?
Yes, sir. Deep learning models we can deploy. But what is going to happen in deep learning, sir? In deep learning, as I've told you, there is something like ANN, CNN, RNN, right? So
Yes,
many
sir.
times when we talk about deep learning, it deals with image data. And there is a basic difference between deep learning and machine learning. Machine learning is something where there is a human intervention. Deep learning is something after some time there is no human intervention. But we can deploy machine learning model as well. Definitely. Okay.
Yes, sir. And also, I guess it will work for larger data as well. Like if we're going with the deep learning, right, sir?
Yes, larger data here, larger why, sir? Because images are there, right? So generally,
Yes, sir.
image data is having huge size. That's why. Okay, so someone is asking a doubt, sir. Can we estimate amount of percentage through DL model along classification? Amount of percentage of what? But like amount of percentage of what? Can we estimate amount of percentage through DL model? So you want to predict? If you are saying predict, yes, we can solve prediction. Let's say color. Okay, yes. If you have data, sir, if you have data, definitely you can. First of all, you need to have that kind of a data, right? See, whatever machine learning can do, deep learning can definitely do that. But vice versa is always not true. If you're asking me, can you do it with deep learning? Yes, definitely. But data set. Okay? Data set is something which is required. Yes. But let me tell you everyone, if someone wants to go into deep learning, you should know machine learning flow, at least the flow. So whether you talk about MLOps, whether you talk about even other fancy topics as well, right? Generative AI, that will make more sense. No, Dr. Siddharuda, no, I told you already. There is no specific criteria. How to decide which algorithm to use? It depends on your knowledge about the algorithms. It depends on your knowledge about the data set. And one more point, as I've told you already, we never depend only on one algorithm in real time. What we do is we try to use 5 to 6 algorithms at a time. So it's always hit and try. But still, if you are asking me which algorithms we use in real time, random forest. If you talk about classification, random forest is one of the best. XGBoost, KNN, support vector machine. These are some of the algorithms which are most common which we use. I hope it makes sense, right? There is no specific rule, sir. Okay. I hope that answers your question. Otherwise, sir, like you tell me, should we take a break or what?
Hello.
Yes.
Hello. You can take a break of 5 minutes, sir, and then we can start.
Okay, then we'll start with the
Yes.
data.
Next session. Yes.
Yeah.
Okay.
Yeah, fine. Thank you. So we'll meet everyone after the 5 minutes break. We'll discuss about Power BI. Okay. Yes, Sheetal madam, I think you will be getting that. I'll share everything with the organizers. No problem.